Hi viewers, so welcome back to the channel. So in this video we are going to discuss the next part of mensuration of class 10 APSSC and NCERT. So it is also useful for all other competitive exams, right? So in the previous video, so we have discussed the basics of mensuration. So that is nothing but, so we have discussed about the formulas of mensuration, right? So if you are having a single solid figure, so different types of figures, so whatever the figures we have, so for all those figures we have learnt the lateral surface area, total surface area and volumes, as well as, so if they are having diagonals, so we have learnt the formulas and we have done problems related to them, right? So for cone, so we have discussed about the slant height and we have found the lateral surface area, total surface area and volume of those particular solid figures, right? So my question is, so does the solid figure exist in a single shape or will there be any combination of solids, right? So if you are having combination of solids, then how will you find the lateral surface area, total surface area and volume of those particular shapes, right? So here we are having only formulas for single solid object. Then how can you find for the combination of solids, right? So this is all the thing that we are going to discuss in this particular video, right? So watch the video till the end. So if you are new to this, so please subscribe the channel and share with your friends, right? Now in this video, so let's begin the topic. So the topic what we are going to discuss is surface area of combination of solids. So when you are having combination of solids, right? So when you are having combination of solids, then how to find their surface areas? So how to find the surface area of those solids, right? So if you observe this particular figure, so what is this? So it is appearing like a milk tanker or water tanker or petrol tanker that we usually see in our day-to-day life. Now is this petrol tank or water tank or whatever the milk tank that we call, is it a simple figure? No, it is not a simple figure, because we can clearly see from this, so it is a combination of three particular solids about which we have discussed earlier, right? So first one is hemisphere, this is cylinder, this is hemisphere. So a water tanker is formed by combination of cylinder with two hemispheres stucking on either side, right? So in this type of figure, so mostly, so we are going to have the radii of, that is nothing but the radius, right? The radius of all those figures will be same, that means equal, so that they can be contacted, so they can be connected without any leakage, right? So their radius will be the same. Now if you want to find, so this is nothing but a new solid which is formed. So if I want to find the total surface area of this new solid, so we cannot directly apply the formula of total surface area of each figure, right? So here we are going to understand one thing. So if you want to find the total surface area of this particular solid, then what we need to do is, so here simply understand that whatever the surfaces that we can see with our eye, the surfaces which we can see, we have to consider only those surface areas, right? Now for this hemisphere, so if you observe this hemisphere, for this hemisphere, when I stuck it with this particular surface, then this particular surface I cannot see, right? So if I cannot see this particular surface, that means what you can understand is this surface area gets vanished. So there is no surface area of this particular hemisphere, right? That means this base area is missing. So when base area is missing, we can consider only CSA, right? So CSA of one hemisphere. And next, coming to this cylinder, so in this cylinder, when on both the sides, if hemispheres are stuck, then these two surfaces we can't see. So if you can't see top and bottom, that means we cannot take the total surface area of cylinder. That's why we are going to consider only CSA of cylinder. Next, on the other part, at the other end, we are again going to have one more hemisphere. So for that also the same situation. So base we cannot see, no. So that's why we are considering only CSA of that hemisphere, right? Now the same way here also we are having a cone and a hemisphere. So individually if you see, then we can see their base areas, right? So when they are stuck to each other, we cannot see them. So that's why we are going to consider only the sum of total surface. So if you want to find the total surface area of the toy, we are considering only CSA of hemisphere and CSA of cone, right? So for all the figures, so this may not be the case, right? So if you are asked to find TSA of the toy, simply write down all the CSS. So it is not the case. So for some particular questions, the conditions may change, right? So those also we are going to discuss in this particular chapter. So when we do problem one by one, so you can easily understand so what we are doing and you can make it easy, right? Moving on to question number 1. So in question number 1, what is given? So exercise 10.2 APTS. So a toy is in the form of a cone. Mounted on a hemisphere. So mounted means nothing but kept above. So a cone is kept above on a hemisphere. And what he has given, the diameter of the base and the height of the cone are 6 centimeters, 4 centimeters respectively. Determine the surface area of the toy. So if you observe here, so did he mention any dimensions about hemisphere? So in the question there is no discussion about hemisphere, right? So if there are no dimensions, how can we find? So that is what we have discussed in the previous introduction. So what is that? So whenever you are having combination of solids, so most of the cases the radii will be the same for the given solids. Okay, now if you observe this figure, so what are the things that are given? So there is a cone above hemisphere, right? So there is a cone above hemisphere. So this is nothing but a cone. So this cone is kept on a hemisphere. So this is nothing but my figure. So my figure looks like this. So once again we are drawing. So my figure looks like this, right? Now what are the things that he has given? So here two types of figures are there. So first one is cone and the second one is hemisphere. So regarding these two, so we are going to discuss in this. So for cone, what are the things that are given? So in cone, diameter of cone, so 2r is given as 6 centimeters and height is given as 4 centimeters. So here these things you need to remember, because here while considering the things, so since a respectively word is used, so you need to read the question carefully. So since diameter is equal to 2r is equal to 6 centimeters, so from this what I can say, r is equal to 3 centimeters. So this is same for both hemisphere and cone. That means what I can say, this is radius of hemisphere also. So radius of cone and radius of hemisphere. So both are nothing but the same things. Now this is 3 centimeters and he has given height of the cone as 4 centimeters, right? So this is 3, this is 4. Now I need to find out the surface area of the toy, and he has given use pi is equal to 3.14 only. Okay, if mentioned then you can consider 3.14. If not mentioned, so go with 22/7. Now what I need to find? Surface area, right? We need to find out surface area of toy. So surface area of this toy is given by, so what are the things that we can see here? Only lateral, so curved surface area of cone, because base is not appearing because of hemisphere. The same way the top of hemisphere we can't see, so that's why we need to consider the CSS of both the figures. So CSA of hemisphere, so CSA of hemisphere plus CSA of cone. So if you want to find the surface area of those figures, So CSA of hemisphere, what is the formula? 2 pi r square plus what is CSA of cone? Since we are not having L value, so directly what I can say, pi r into root over h square plus r square, right? So from both the things I can take directly pi as common, so 2 into what is radius here, so radius is 3 square plus here pi is taken common, so 3 into root over, so 3 square plus 4 square, right? So 3 square plus 4 square is nothing but 5 square only, no? So pi is nothing but 3.14 into 3 square is 9, 9 2 sir 18 plus here root over 3 square plus 4 square is nothing but root 5 square, which gives me 5, 5 3 sir 15. So what is the value of 15 plus 18? So 15 plus 18 is nothing but 33. So 3.14 into 33. So let us multiply that. So 3.14 into 33. So when we multiply 4 3s are 12. So 1 will be carried. So 3 1s are 3 plus 1 4. Next 3 3s are 9. The same way here also in the next line also we are going to get 942. Then on adding this, so I am going to get 10362. Now since we are having two decimal places, so 103.62 is the answer. So from this what I am going to get? So 103.62 centimeter square. So this is nothing but my total surface area of this particular toy. Okay, likewise we can find out the answer. Next, moving on to one more question. So when questions changes, so the different types of conditions we can observe here. So this is nothing but a solid, so which is in the form of right circular cylinder with a hemisphere at one end and a cone at the other end. So for this particular thing, so we are having a cylinder. So we are having a cylinder. So to this cylinder, so let us draw it vertically. So there is a cylinder. So cylindrical shape, to this cylindrical shape at one end, so what I am having? So at one end I am having hemisphere and at the other end I am having a cone. So this is nothing but the given figure, right? And he has given radius of the common base is 8 centimeters. So this is 8 and this is also 8. That means hemisphere radius, cylinder radius and the cone radius all are 8 centimeters. Next he has mentioned heights of cylindrical and conical. Cylindrical and conical are 10 centimeters, 6 centimeters respectively. So if he is mentioning respectively, that means we need to follow the same order. So first he has talked about cylinder. So cylinder height is 10 centimeters and then the height of cone is 6 centimeters, right? And from this, so we are going to find out next what is asked to find total surface area of the solid. So here also he mentioned use pi is equal to 3.14, right? So let's move on doing this problem. So have you understood how we have taken the figure? So by using this figure, so we can directly understand so what to do, right? Next talking about, so first we are talking about cone. Next, so after cone, so cylinder, and next hemisphere. So write down their dimensions. So what are the things that are given? So for all the things radius are same now. So radius is equal to how much? 8 centimeters. So for this also radius is equal to 8 centimeters. So for this also radius is equal to 8 centimeters. So hemisphere completed. Next about cone. So about cone, height is given as 6 centimeters and for cylinder height is given as 10 centimeters. So these are the required things. So these are enough to find out whatever the things that we need. Now what I need? TSA of new solid, right? So if I want to find the TSA of the solid, so what are the things that I need to consider? CSA of cone, because we cannot see the base of cone. Next CSA of cylinder, because we cannot see the base of cylinder, right? Bases of cylinder. Next CSA of hemisphere. So when I add all these three, I am going to get the total surface area of this solid. Next, CSA of cone is nothing but pi r into root over h square plus r square, plus CSA of cylinder is nothing but 2 pi RH. What about CSA of hemisphere? 2 pi r square. So among all these, so what I can take common? So if I take pi as common, next value of r is 8 into square root of 6 square plus 8 square, plus here since pi is gone, so 2 into radius is 8, height is 10, plus 2 into pi is taken common, no, so r square means 8 square. Now directly substitute the value, so pi is equal to 3.14, square root of 6 square plus 8 square is nothing but 10 square, which is nothing given as 80, plus now 82 sir 160, plus 8 square is 64, 64 2's 128. So what is this value? 80 plus 160 is 240, 240 plus 100 340, 350 368. Now from this what I am going to get? 3.14 into 368. Now do multiplication, so 368 with the 3.14, so 8 4s are 32, so 3 is carried, 6 4s are 24, 3 27, 2 is carried, so 4 3s are 12, plus 2 14. Next with 1, so 1 8s are 8, 1 6s are 6, 1 3s are 3. Next 3 8s are 24, so 2 is carried, so 3 6 are 18, 18 plus 2 20, 2 is carried, 3 3s are 9, 9 plus 2 11. Now when I add all these, so 8 8 16 plus 1 15, now 6 4 10 14 15, so 1 is carried, so 3 plus 1 4 plus 1 5 double 1. Now since we are having after 2 decimal places, no, so what is the answer then? So double 1 5.52 centimeter square. So this is nothing but the surface area of this total toy, right? Next, moving on to one more question. So here a medicine capsule is given. So medicine capsule is nothing but similar shape as my water tanker, right? Now what he has given? A medicine capsule is in the shape of a cylinder with the 2 hemispheres stuck to each of its ends. The length of the capsule is 14 millimeters. The length of the capsule is 14 millimeters and width is 5 millimeters, and find its surface area. So we need to find out its surface area. So you need to find the surface area, right? So if you observe these things, so carefully, what he has given, the length of the capsule is 14 millimeters. So length of the capsule means, so from here to here it is 14 millimeters, right? Now since it is 14 millimeters and the width of the capsule is 5 millimeters, so if width of the capsule is 5 millimeters, that means, so what is width here? So width is nothing but diameter only, no? So width is nothing but diameter of the capsule, that means diameter of hemisphere, right? So diameter of hemisphere is 5 millimeters. Now from this what I can say, so if you want to find the particular thing, see here, so this is nothing but my cylindrical portion. To this cylindrical portion I am having two hemispheres stuck at both the ends, right? So if I draw it clearly, so one more we will try. So there is a cylinder, so to this cylinder, so on both the ends I am going to have two hemispheres. So two hemispheres are stuck at both the ends, right? Now if you observe, he has given that, so this particular diameter is 5 millimeters. So if I say this particular thing is 5 millimeters, then this particular radius is 5 by 2 millimeters. No, if this is 5 by 2 millimeters, then this is also 5 by 2 millimeters, right? So this particular part is 5 by 2 millimeters, and this particular part is also 5 by 2 millimeters. So from this what I can say, so 5 by 2 millimeters plus 5 by 2 millimeters gives me 5 millimeters. So if I want only the length of cylinder, so if I want only the length of the cylinder, that is nothing but height of the cylinder, then what I should do, so 14 minus 5 millimeters. So what is 14 minus 5 millimeters? So it is nothing but 9 millimeters. So height of the cylinder is 9 millimeters. So from the figure we have deduced that, right? So if you know height of the cylinder, then directly we can go with the problem. So what are the things that are given? So first about cylinder. So about cylinder if we talk, so radius is commonly we know, so 5 by 2 millimeters. So for hemisphere also, radius is 5 by 2 millimeters only. Next, what about height of the cylinder? So height of the cylinder is nothing but 14 millimeters minus 2 times of the height of the hemisphere. So this 2 I can cancel it out. So from this what I can say, so 14 minus 5, which is equal to 9 millimeters. So height of this particular cylinder is 9 millimeters. So since I got all the dimensions, right? So when I know all the dimensions, directly I can go with surface area. So surface area is nothing but CSA of cylinder plus, since both the hemispheres are congruent, so I can directly take 2 times of CSA of hemisphere. I can directly take 2 times of CSA of hemisphere. So CSA of cylinder is nothing but 2 pi RH plus 2 into CSA of hemisphere is nothing but 2 pi R square. Now since both the things are having, so what I can write it as, so here he did not mention to take pi as 3.14, so I can directly take it as 22 by 7. So I can write it as 2 into 22 by 7 into radius is 5 by 2 into height is 9 by 1 plus 2 2s are, so here 4 by 1 into 22 by 7 into what is radius here, so 5 by 2 into 5 by 2. Now from this, so these two I can cancel out. So this 4 and these 2's I can cancel out, right? Now 22 5s are, so 22 5s are 110, 110 9s are 990 by 7 plus here 22 5s are 110, so 110 5s are 550, so 550 divided by 7. So from this, so directly I can add 7, so I can directly add because 7 is the same thing. So 990 plus 550, so what is the value of 990 plus 550? So 0 plus 0 is 0, 95 is 14, so 1 is carried, 95 14 15, right? So in 7 table, so 7 2s are 14, next 7 2s are 14, so it is nothing but 220 millimeter square. So this is nothing but the surface area of that particular medicine capsule, right? Next, moving on to one more question. So question number 4. So two cubes each of volume 64 centimeter cube are joined end to end together. Then find the surface area of resulting cuboid. So here you will understand, so we are not going to consider the CSS or LSA, right? So in this particular problem you will understand everything, right? So here what is given, two cubes each of volume 64 centimeter cube, right? So there are two cubes, so there are two cubes given. So this is a cube, right? So this is a cube. So to this cube, so we have joined So let's draw once again. So there is a cube. So this is nothing but a cube, right? So to this cube, so one more cube is attached. So there is one more cube attached. So if you extend this in the same way, then we are going to get, so one more cube. So there are two cubes, so which are attached one on each other by end to end, right? So these are nothing but the back parts, so which you can see if it is a transparent one. So these are nothing but the two cubes which are stuck to each other end on end. So he is saying end on end. So these are nothing but the things, right? Now he is asking you to find out the resulting cuboid's surface area. So this is nothing but a cuboid, right? Now what he has given, so volume of cube is given. So volume of cube, what is the formula of volume of cube? So volume of cube is nothing but side cube only, no? So side cube or edge cube. So side cube is equal to 64 centimeter cube. So from this, what is the length of the side? So side is equal to 8 centimeters. 8 or 4. So since 4 cube is 64, so we get side is equal to 4 centimeters. So when I write these as 4, and breadth will be 4 and height will be 4. So if you observe this length is 8, right? Length is 8, breadth is 4, height is 4. So when you are having length 4, so length is 8, breadth is 4, height is 4, that means we can clearly call it as a cuboid, right? So if I want to find the surface area of this cuboid, so how can I find out the surface area of cuboid? So we know the formula, right? So surface area of cuboid is equal to, so what is surface area of cuboid? So here surface area means total surface area. So 2 into LB plus BH plus HL, right? So you remember this formula, no? So 2 times of, what is LB here? So here length is 8 centimeters, breadth is 4 centimeters and height is 4 centimeters. Now when I substitute these values, so this is 8 into 4 plus 4 into 4 plus 4 into 8. Now from this what I am going to get, 2 times of 8 4s are 32 plus 4 4s are 16 plus 4 8s are 32. So 32 plus 32, 64, 64 plus 16 is nothing but 80. So 2 times of 80, so which gives me 2 80s. So 2 80s are nothing but 160 centimeter square, right? So what we got, so it is nothing but 160 centimeter square. So this is nothing but, so what we have found here, so we have found the surface area of cuboid. So this we can also do it in the other way, right? So the other way, so other approach is nothing but, so if you observe, we know the surface, total surface area of cube, no? So what is TSA of cube? So TSA of cube is nothing but 6a square. It is nothing but 6a square, right? Now if you observe the figure, in this particular figure, these two faces are attached end on end, no? So when these two cubes are attached end on end, that means one face of this particular cube and one face of this particular cube gets disappeared, right? That means we will be having only 5 faces of this particular cube and 5 faces of this particular cube. That means here from the first one we are going to get 5 faces and from the second one we are going to get 5 faces. So each face is nothing but a square, so you can directly take it as 5 plus 5 into a square. So which gives me 10a square. So here each side length is 4, so a is 4, so 10 into 4 square is 16. So what I got here, 160. So did I get the same answer? So 160 only. But is there any formula 5a square for cube? So there is no. See So lateral surface area of cube is 4a square, but here what we got here, 5a square, right? So have you understood? So everywhere we are not going to use the concept of CSA of those particular figures. So based on the questions, so we are going to have the considerations. So here for the cube we can take 5 faces, because 5 faces we can see, 6th face is covered by the other cube, and for the other cube the same way, by means of first cube one face is covered. So because of that we are going to get 5 plus 5, 10 faces only out of 12 faces. So if you take individually, you are going to get 6 faces from this and 6 faces from this, but when you combine, so we are having 2 faces less. So based on that we can find out the surface area of this cuboid, right? So thank you for watching the video. So in the next video we are going to discuss remaining problems.